You're listening to the Frontier Tech Hub, supported by the Foreign, Commonwealth and Development Office. Thanks for tuning into this story. Patrick's story. The future of robotics is the Millennium Falcon. Luke Skywalker wasn't exactly impressed when he first laid eyes on the Millennium Falcon. It was old, worn down, and far from the sleek, high-tech starship he was probably expecting when he hired Han Solo to transport him and his friends from Tatooine to Alderaan to escape the stormtroopers already on their tail.
What a piece of junk!
She'll make 0.5 past light speed. She may not look like much, but she's got it where it counts, kid. I've made a lot of special modifications myself.
These are two iconic lines from the first ever Star Wars film released in 1977, which gave birth to a loyal fandom for a legendary starship which became the world's most beloved hunk of junk. Over the course of several films, we see the Millennium Falcon endlessly malfunctioning. Han Solo and Chewbacca, two nomadic travelers living outside the realms of traditional society, fix her up with sheer willpower, duct tape, and whatever tools they can find locally available. And right to the end, she never lets them down. Thousands of light years away in the real world, we haven't quite reached the kind of space travel depicted in the Star Wars universe. But we're getting close to the realms of robotics like R2-D2 and C-3PO. There's an abundance of stock images depicting robotics today, and it's starting to look very futuristic. They're often sleek, humanoid machines that can walk alongside humans and even dance with them, autonomous wheeled bots delivering takeaway food to consumers, or polished, gleaming robotic arms whizzing around at breakneck speed as humans with clipboards watch over them. But there's an alternate future of robotics which looks very different, and it's one where robotics are helping to solve the most urgent challenges of our time. That future, the future of robotics for development, is messy, modular, and built for real-world conditions, just like the Millennium Falcon. The catalyst for robotics in development. Dr. Patrick Meier first realized the potential between humanitarian work and robotics in 2008, when he stumbled across a project at the Polytechnic University of Torino where they were collaborating with the World Food Programme to build drones, flying robots that can be controlled remotely by humans or fly autonomously using software-controlled flight plans.
So I was interviewing some folks in Rome for a UN Foundation project about emerging technologies and disaster response. And as soon as I heard about this possible project up in Torino, I hopped on the train and met with the professors and students who were building these drones at the time, even though there were no regulations and it was costing an arm and a leg and it was extremely difficult to use. But that really just hooked me. And I thought to myself, that this is something to watch. It's obviously first efforts, first generation. It's always the hardest. And so I kept that in the back of my head. And then it wasn't until Typhoon Haiyan in 2014, November, December 2014, 6 years later, goodness, I was seconded to the UN response efforts, specifically focusing on innovation and technology. And within a day of arriving in Manila, I'd come across half a dozen teams, companies mostly using small drones for the response efforts. And I thought to myself, okay, now's the time. This is really, really happening.
Patrick was right. Typhoon Haiyan was the worst typhoon to hit the Philippines and marked a milestone for drone use in disaster relief, showing how they could be used at full scale to chart disaster areas, locate victims, and deliver supplies to isolated survivors. But amidst the incredible support drones were providing, Patrick also spotted vital concerns in the moment. Tech-centric teams and disaster response groups were working together with no understanding of how one another organizes. Data wasn't being shared with local government or communities. Some drones were flying in the same areas without coordinating with one another to spread their support.
And so that's when I got back home after that, I started writing a code of conduct. Not because I'm good at writing codes of conduct by any means. In fact, it's not my preferred exercise, but I realized it was super, super important. So I wrote a first bad draft, and then I begged a lot of very smart, clued-in people to help improve it. And that's continued to become kind of the gold standards after numerous revisions as a code of conduct. So then, with the help of the Rockefeller Foundation, I was able to convene a meeting at the Bellagio Center of the Rockefeller Foundation. And that was phenomenal. We brought such a great mix of experts from the drone technology space to the humanitarian space, as well as academics who brought in real rich insights on the ethics and everything else. And for some reason, this has hardly ever happened in my life. For some reason, the 21 of us managed to take a poorly written first draft of the code of conduct that only was a page or two and turn it into a full-fledged, really very well-written code of conduct in 72 hours. And that is unheard of in any kind of humanitarian meeting. come up with an agreement on standards and best practices and do's and don'ts, and it just worked beautifully. And then a couple of years later, we updated it again because technology moves fast, of course, and it's still the go-to for many of these humanitarian drone projects.
The technology did move fast. A few years later, in 2017, the world's first humanitarian drone corridor would open in Malawi, later followed by the first African Drone and Data Academy. And since that same year, the Frontier Tech Hub began to explore drones too, with pioneers from the Foreign, Commonwealth and Development Office. Pilot teams tested the use of drones to transport tuberculosis samples from Mozambique, fly vaccines to remote areas in the mountains in Nepal, and even spray Brazilian forests from the sky to prevent wildfires. All supported by the humanitarian UAV Code of Conduct instigated by Patrick, who knew to ask the right questions at the right time. Homegrown robotics. It's been 10 years since Patrick convened experts to explore the ethics around drone use in humanitarian work at the Bellagio Center. Now, alongside the Frontier Tech Hub and champions at the Foreign, Commonwealth and Development Office, he's convening experts again.
So it's like a dream project. I couldn't believe it when I first got wind of this project that a team was looking at the role of robotics beyond drones in the context of global development, so the Sustainable Development Goals, and how robotics might help advance the SDGs, specifically in low and middle income countries. And that just is bringing all my areas of interest together in one place. And it's so timely as well. The FCDO is particularly keen to better understand the role of robotics in development for the next 5 years to help inform their decision-making around programs, strategy, pilot projects. And so it's just a terrific intersection of interests and opportunities happening at the same time.
The opportunities for robotics in development are vast, spanning agriculture, health, infrastructure and waste management. And crucially, it's about supporting humans where they need help most, not replacing them. As climate change impacts farming communities, agricultural robots can continue working in extreme heat, inspect infrastructure in dangerous areas, and process waste safely and sustainably. Robots are generally made to lighten the hardest loads, the dull, the dirty, and the dangerous. In order to really surface the opportunities and explore how enabling environments for robotics in development might be designed, convening a global group of experts was crucial.
We had 8 experts coming from a wide range of areas of expertise as well as geographies. So we had experts from Nepal, from Iraq, from South Africa, Nigeria, Mexico, the US, and Europe. And they worked so well as a team, just really building on each other and just contributing some great insights and really grounding the exercises in their first-hand experience, and you can't ask for more. You know, we are not the experts on robotics and the opportunity of agriculture robotics, for example, in northwestern Nigeria. But the expert from Nigeria is. And so they have obviously the lived experience and the firsthand knowledge of what the opportunities actually are, what the challenges actually are. And those kinds of insights, you just can't get anywhere else. You just can't. So then when you could hear from Adewale in Nigeria about, here are the challenges, here are the opportunities. In fact, it's not what we might have assumed, right? From thousands and thousands of miles away. And, they're able to really ground it in firsthand experience, or to hear from Mariam in Iraq, who is involved in and also building maker spaces for Iraqi youth and sharing what the opportunities and challenges are there, not only in Baghdad, but also in northern Iraq, where she's also working, was absolutely tremendous. Hearing from Bikash in Nepal about the opportunities and challenges of robotics as well was phenomenal. And it was so interesting. They would all bring in amazing insights that I would have never thought of in a million years.
One key desire which kept coming up within the group was to have more of an enabling environment with fewer barriers. Experts in the group described importing Raspberry Pis as a headache and hugely expensive. Importing technology components into low middle-income countries can be 2 or 3 times the cost and incurs additional import taxes. And even if countries opt to import robotics, they're faced with huge prices to buy robotics which provide hundreds of features when they probably only need 4 or 5.
One of the groups decided to look at this idea of the right to repair, which is coming out of the need to enable, consumers to be able to fix their own phones and laptops and so on, rather than having to buy the next model, just because apparently that's what everybody needs to do these days. And so there's been this movement in the US and Europe to try and enable, trying to shift the power back into the hands of the consumers. And this is going to be super important from the context of robotics, because as you are transferring technology, if you're creating dependency by requiring that technology to be shipped back to whatever country for it to be repaired, that's just disaster. That's absolutely a disaster. And I've had first-hand experience of seeing this happen and being appalled by it. And so this idea of saying, let's work with local experts to build the capacity, build the expertise to actually repair these robotic solutions, so you don't have to wait 3 months and spend tons of money and waste tons of time waiting for the platform to be, rebuilt or fixed or what have you. So this idea of empowerment is super important, and not creating dependency with technology is hugely important, because it's not just dependency, it's really a power dynamic at the end of the day, right? That's just not what we want to do with robotics, which is also why it was amazing to have a number of roboticists / entrepreneurs from countries like Nepal and Nigeria and Mexico, because they're telling you this firsthand, So anyways, long story short, they decided to look into the idea of the built to repair as a future world. In this future world, policies around built to repair are in place. There's enlightened leadership in this space. And the other axis, they chose to look at the democratization of education. I love this idea of saying, okay, if in this world where there's a right to repair, that means we can be innovative in the kind of how we get the spare parts. Maybe instead of using yet another, steel-based component, we can actually be more innovative, source locally, take some kind of material that is biosourced material that will biodegrade, that will be much better for the environment, and maybe is able to, as a result, absorb more of a motor vibrations, or I don't know what, right? So it's actually more durable as well. So what was beautiful about this idea is this future that they were painting for. It's like, we can take bits and pieces of robotic solutions from different countries, including the global north, but then we can make it ours, because there is a right to repair, because it's modular, it's more robust, and we can actually potentially even enhance these robotic solutions. And there was one comment along the lines of, you bring in, this was from a roboticist in Africa. He said, we can bring in a super sophisticated agriculture robot from Germany, and chances are it won't last more than a few weeks in Nigeria. But you take a Nigerian agriculture robot, it'll work perfectly fine in Germany. right? Because in Germany, all the fields are nice and flat, everything is marked, everything is structured, and so on. So if our robots can work in unstructured, more challenging environments in Africa, they'll work anywhere else. And there's an opportunity for these entrepreneurs. The markets in Africa and Asia and Latin America are much bigger as well. So I loved that. I loved, it's not about, binary, black and white, but it's a both and. We can take that and we can make it ours and bring it back, bring it back to the rest of the world.
We need robotics that are practical, not perfect. Patrick's optimism is infectious for all the right reasons. Alongside this diverse team of collaborators, he's advocating for locally driven innovation, where robots are tailored to a community's needs rather than imported from the global north. And there are clear levers to pull to help this shift. Governments need to reduce import costs on key robotics components, and funders need to support local makerspaces and incubators to foster homegrown robotics innovation, many of which already exist.
In the Star Trek universe, everything works. It's beautiful. The screens are beautiful. It's touchscreen. Everything is slick. It's basically Apple on steroids. It's what I think a lot of these tech bros in Silicon Valley want their future to look like, right? Then you have the Star Wars universe, where these droids break down all the bloody time. And so you have Han Solo hacking and banging against I don't know what in the Millennium Falcon, R2-D2 flipping over, C-3PO's got sand all over his circuits. And so he's having a bit of a hard time, right? And what I like about that is these robots are repairable on site. They're being, switched with different parts and so on. The Millennium Falcon is, you rip a part out, you put a new part in. And I think that future feels more real, feels more like, in a way, the real world. And I think that's where things are headed. And it's open source, it feels like, right? These are right to repair. Luke Skywalker is not asking Darth Vader, can I repair R2-D2, right? You just repair it locally. And so that ability to just hack and have that self-reliance and self-sufficiency, I think that's the kind of future I'm seeing when I'm receiving these amazing videos from these roboticists and entrepreneurs from around the world saying, look, this is what I'm building. And it's there, it's real.
The Millennium Falcon wasn't the fastest ship in the galaxy because it was perfect. It was fast because it was hacked together, endlessly repaired, and constantly improved by people who knew how to work with what they had. That's the real future of robotics for development. It's not about shiny, untouchable machines that need sending off for every fix. It's about real, practical, adaptable technology built by the people who need it most. Thanks for listening to this Frontier Tech audio story. To discover more stories like this one, you can visit frontiertechhub.org.